Yes, the resistance R actually discussed what rho L upon A. The resistivity, how it changes with the temperature, nature of material, we have discussed. Okay. So the temperature coefficient of resistance, yesterday we have discussed what alpha is equals to different equations we have discussed. That is rho, if the initial temperature is 0 degrees Celsius, by rho naught into T, one equation. Another equation, rho 2 minus rho 1 upon rho 1 T2 minus rho 2 T1. We have to use it when the temperatures are more. And this in differential form, we write it as d rho by rho into d. Okay. But observe, actually same formula, yesterday when we come to numericals, we used it as alpha is equals to RT minus RO upon RO into T. And in numericals, directly we use it as like R2 minus R1 upon R1 T2 minus R2 T1 also. Okay, this is equals to yesterday we used in one problem dr by R into D. Okay. We derived for rho, but we are using for resistance. Is it correct, sir? If we discuss. Okay. Still a lot of board is there. We are not using it properly. Okay, good. From here we have to use. Okay, we understood. Now, slowly learning. Still some board is there. Oh my God. Okay. So we start from here. Right. Perfect. So alpha is equals to, yesterday we used dr by r into dt. Is it correct? Derived for rho, but using for resistance. Okay. Then they say here, compared to the changes of resistivity values, the length and area of cross section, their variations. Why? Because actually what I have to write here, d of rho L by A upon dt times R, rho L by A initial. Rho changes with the temperature, length changes with the temperature, area of cross section changes with temperature. All are changing, and directly you can't write this is equals to d rho by rho into dt unless and until you take L and A common taken out and cancel at the numerator and denominator. Okay. And you are accepting that dr by r into dt is equals to d rho by rho into dt. That means compared to the variations in the resistivity, the changes in length and area of cross section are negligible. That's why we are taking the temperature coefficient of resistivity as the temperature coefficient of resistance. That's why we say here the temperature coefficient of resistivity. Oh my God. Here I write it is temperature coefficient of, today we write either resistivity or resistance. Okay. By considering, since the expansions in length and area of cross section are neglected. Okay, that's why even though derived for length and area of cross section, derived for resistivity, we can use it for resistance. Okay, Nana? This is temperature coefficient of resistance. From here, we are going to what? We are going to the resistance changes by changing the length and area of cross section. Okay, and how you change the length and area of cross section? If you ask, we say here resistance, what we have written yesterday, rho L by A. For the same material at the same temperature, rho is constant. So you can write R is directly proportional to L by A at the same temperature for the given material. So here what I say, if I change only the length, okay, only the length, then I write R is directly proportional to L if A is constant. Without changing the area of constant, how can you change the length, sir? Simple. This is one wire. Of length L. Its resistance is R. Okay. It is cut into, suppose, 2 equal parts. Then the resistance of each part. And ఈ టైంలో R/2 exactly. That's what I am trying to say. అంతేనా శ్రీనిధి? Resistance of each part. And only length kada nana changing here. When the wire is cut into 2 equal parts, only length changes. Length becomes half. So resistance also becomes half. Why? Because R is directly proportional to L. So we say here dash. Then we write what? Here R is directly proportional to L. Length becomes half. So resistance becomes half. R2 is equals to R/2. Directly we can write. Okay, I think you understood. There is no doubt here. Okay. And suppose same, we just remember like a formula. If it is cut into n equal parts, directly you can say the answer. R/n. Yes, good. Into n equal parts. It is a simple question. Then R2 is equals, everybody can understand. So answer is R2 is equals to, without explanation, we can write it as R/n. Okay, Nana? This is first board, right? So they scroll చేసి పైకి వెళ్తున్నాను నాన్న. Moving up here. ఏంటి వెళ్ళాలనుకుంది? Right. Bit going up here. ఇక్కడ suppose if area of cross section is suppose changed and a wire is cut, okay, if L is equals to constant, for a given material, we can write R is inversely proportional to area of cross section. As a circle, circular cross section, we can write R is inversely proportional to R square. Okay. Right? And aim లేదు నాన్న దీన్ని. For example, ఒక wire ఉంది. This is of radius of cross section. The length L we are taking. But in this, what we are doing, some part is cut and removed. Its resistance is R nana before cutting. Okay, this part is cut and removed. This much part, and then this is removed. How you remove, sir? Radius of the wire is R, and that of part cut and removed is R by 2. ఇప్పుడు మీరు చెప్పొచ్చు కదా నాన్న, ఇంత పార్ట్ కట్ చేసామంటే what will be the area of cross section previously? Pi R square. ఇప్పుడు area of cross section of the wire is pi R square minus this part, area of cross section of black one. Okay, and here then R of that wire is changed as dash. Okay, chala simple. You can say initial area of cross section as pi R square and resistance as R, what he has given there. Final area of cross section konta part cut and removed kabatti pi into R square minus R by 2 whole square. Correct enna? This is the area removed. A into pi into R, sorry, A2 equals to pi into R by 2 whole square. Cut and remove. Okay. So here A2 becomes how much? Pi into, after removing, you are getting 4 minus 1 and 3R square by 4. Area is equals to 3 by 4 times of A1. Inversely proportional kada. I think directly you can say R 4 by 3. Very good. R2 is equal to inversely proportional kabatti 4 by 3 times R1. Okay. It only the area of cross section is changed. Okay. Into line level. Where are the lines here? Okay. Slowly we are understanding the points. The actual. What is this? Yes. Better we go to bed. Here, Nana. Just in the middle, trying to search for the tools, Nana. Okay. Then here, if length and area of cross section are changed, how to find the resistance we have discussed. Okay. Ante here in the formula R equals to rho L by A. If you change the rho, how the resistance changes? If you change the length, how the resistance changes? If you change the area of cross section, how the resistance changes? Here are few models we have discussed. Okay. ఇంకా కొద్దిగా ముందుకు వెళ్ళాలి అంటే టు గో డీప్ ఇన్ టు ద కాన్సెప్ట్ వి రిక్వైర్ సమ్ అడిషనల్ ఇన్ఫర్మేషన్, ఇంకా కొద్ది కావాలి మనం టు ఎంటర్ ఇన్ టు ద ప్రాపర్ న్యూమరికల్స్. ఓకే, అన్నప్పుడు వాట్ యు రిక్వైర్స్ ఆర్ అట్లీస్ట్ హౌ టు కనెక్ట్ ద ఎఫెక్టివ్ రెసిస్టెన్స్ ఇన్ సిరీస్ అండ్ ప్యారలల్. ఓకే, మరి ఆల్రెడీ వి డిస్కస్డ్ ద కెపాసిటర్స్ ఇన్ సిరీస్ అండ్ ప్యారలల్ కాబట్టి ఇట్ ఈస్ వెరీ ఈజీ టు ఎక్స్ప్లెయిన్. So first I am coming to what? Find the resistance in series. Okay, and a series combination we are starting. Okay, and in the series combination, here what you require, sir? In series combination, మీకు తెలిసింది జనరల్లీ రెసిస్టర్ సింబల్, సర్క్యూట్ సింబల్, ఇట్ ఈస్ ద సర్క్యూట్ సింబల్ ఆఫ్ రెసిస్టెన్స్. ఇలా వీఆర్ టేకింగ్ 2 or 3 resistors, end to end connection you already know in capacitors is called as series. So one is connected to the second is connected to the third. But as usual we maintain some potential difference for the current flow. So for the current flow, we are maintaining the potential difference. You know in the capacitors chapter how you maintain the potential difference. That will be maintained by connecting it to a cell at a potential difference V. And immediately current starts flowing. Current starts flowing in what direction? From high potential to low potential. So this is high potential positive, this is low potential negative. So outside the circuit, means outside the cell, here the current flows from high potential to low potential, and this is the direction of current. Okay, that current flows through first resistor. Same current without dividing flows to the second resistor, and without dividing same current flows to third resistor. And it crossed 3 speed breakers in its path. Who? The same person. Same current passed over 3 speed breakers and finally reaches to the home and a cell. Okay, and here like in capacitors, who is constant? Nana? Charge. Kada? In the same way here, who is constant in series combination without splitting and a current? Very good. Current I is constant. So first point we say I equals to constant. So quickly we write constant means ratio saying is very easy. I1 is to I2 is to I3 is equals to 1 is to 1 is to 1. Very simple. Okay. So next, మనం ఇంకొద్దిగా కిందకి వెళ్ళాల్సిన సమయం ఆసనమైంది. After writing I1 and I2, I3, then you check here the potential, total potential, like in capacitors between these 2 points will be divided like V1 plus V2 plus V3. I think you require a detailed explanation. You have some idea in capacitors. Okay, idea on the other nana? Like V1 here, V2 here, V3. Right. In the same way here, total potential will be divided like V1 plus V2 plus V3. That point here I am going to write. Okay. I am writing here. ఇదేంటి ఇది ఎలాగా? Oh, it's fixed up. Sorry. Then coming to here, total potential difference V is equals to, we write it like V1 plus V2 plus V. Incoming call from Sridhar Krishnan here. Okay. Whereas V1 is equals to how much you write, and actually I1 into R1 I have to write. Right. Ratio you are saying. Exactly, Srinivitya. Okay. I1, but I is constant kadana, same I we write. V2 is equals to I into R2. V3 is equals to I into R. Okay. So ratio what she is saying, V1 is to V2 is to V3. Exactly. I cancel in all the 3. So you will get the ratio R1 is to R2 is to R. No problem. Okay. And total we have to write I times R1 plus R2 plus R3. That is equals to across the total combination The current is same. What is the total resistance across that combination? That only we are going to find out. And R equals to how much? Therefore, that R equals to R1 plus R2 plus R3. It already we discussed. It is just like the capacitors in parallel formula when you come to resistors. But it is in series. Yes, exactly. Right? Good. Mari here V1 ratio of potentials discussed, ratio of currents discussed, total potential discussed, effective resistance discussed, and when they are identical, ఇది కూడా మనం like in capacitors we can write here for identical resistors. NR, very good. చూసారా? The points are becoming very easy. Identical resistors. We write RS is equals to NR. In parallel, there we wrote NC. For identical capacitors in parallel. In the same way, NR here. Okay. And they are directly added. So you can say here, what can you say there? Greater than greatest. Exactly. Okay. Greater than greatest. All right. So we are trying to take it there. Greater than greatest. Okay. ఓహో దీంట్లో చాలా ఉన్నాయి. రైట్, నువ్వు వెళ్ళవే. అమ్మయ్యా, came back to here. So effective resistance RS is greater than greatest individual. Okay, ika idi series nana inte quick ga we try to finish parallel also. Okay, parallel grouping. Parallel grouping ante you know that how to connect them in parallel. Okay, here only between 2 points if you connect V constant there. Exactly. And the 3 resistors are connected between only 2 points, keeping V constant across them, maintaining some potential difference here by connecting it to a cell of voltage V. So here first point what we write, ide better than ana cheto draw cheskundam. Here V equals to constant, first point we write. That implies what can you write? V1 is to V2 is to V3 is equals to 1 is to 1 is to 1. Yes, exactly. And second point what we write here, current will be splitted. I splitted like I1 across first one, I2 across second one, I3 across third one. Yes. I1 is to I. Right. Correct, Harsham. So total current here in the circuit, we write that current only divided like I1, I2, I3. So total I will be I1 plus I2 plus I3. Okay. Where I1 is equals to, actually we have to write V by R according to Ohm's law. V1 by R1, but we write it as V by R1, V constant. So I2 is equals to V2 by R2, again we write V only. And I3 is equals to V3 by R3, V3 again we write V only. Okay, reason behind V constant. The ratio already you posted that I1 is to I2 is to I3 is equals to, by cancelling the V at the numerator, you are getting 1 by R1 is to 1 by R2 is to 1 by R2. Exactly. Okay, by substituting I equals to V by R here and cancelling V on both sides, you will get effective resistance 1 by R equals to 1 by R1 plus 1 by R2 plus 1 by R3. Just like in the series grouping of capacitors, just like. Okay. Right. Okay. So here this is the effective resistance. Right? Vertical అయిపోయినట్టుంది ఇంకా ఉందా okay okay here so we can write since it is in reciprocal okay R in P parallel we write is smaller than smallest yes exactly lower than lowest individual. And here we write for identical resistors. Okay, what we write for identical resistors? Rp is equals to R by N. Exactly. Yes. For two resistors, man ketla oka shortcut undi kada nana. Two resistors in parallel. What we write for two resistors? Rp is equals to R1, R2, like C1, C2 by C1 plus C2 in series. We write R1, R2 by R1 plus R. Okay, Nana? Good. Right. This is briefly the resistors in parallel and series. I think all of you follow. Nothing complexity in this series and parallel grouping of resistors. Okay. Yes, that is very easy. అసలు ఇప్పటికే మనం చాలా టైం వేస్ట్ చేస్తాం unnecessarily discussing the things. Okay, so related to each, what we are doing now here, దీన్ని హైడ్ చేయలేం రా. Yes, ఇప్పుడు for example, instead of cutting the wire, instead of cutting some cross section from the wire, అలా కాకుండా suppose they say one liquid is taken, దీంట్లో షేప్స్ లేవా? What is this? నేనేం డ్రా చేయాలి? ఉన్నాయి రోయి, రైట్. ఏది ఏం రాలేదు? Right. Yeah. Oh, right. Now I understood. Now suppose here I am taking a liquid in ఇది రాలేదు సరే in a test tube up to here. Okay, whose length is L, area of cross section is A. Okay, it is transferred into another test tube of double the length of double the length, okay, 2L, area of cross section, area of cross section not given, length double, okay. Same liquid is transferred into this test tube, okay. The question is, when the liquid is transferred, yes, transferred into another test tube, okay, then the resistance of liquid becomes okay. Just once you check now, double the length if you transfer, okay, and here the length of liquid becoming yes, exactly. Length becomes 2L and volume of liquid remains same there and here. Same volume of liquid is transferred into another tube, but to a length 2L. Okay. Volume remains constant in this case. Okay. Volume is equals to constant means area into length is equals to constant. This is 4R. Yes, exactly, correct. A into L is constant. Area becomes A by 2, or you can write L is inversely proportional to A from this, whereas resistance is directly proportional to L by A. That 1 by A I am replacing with L into 1 by A. That is replacing with 1 by A replaced with L1. And R is directly proportional to L square. Okay. And the liquid is transferred. And the main concept you try to focus here. If volume remains constant and not the length, not area of cross section, don't focus on that. If volume remains constant in a case, then resistance is directly proportional to L square. This is the formula to be used. Okay. Directly choose length is doubled because the resistance is also doubled. If you say, answer will be wrong. Okay. So here what we have to say, because length okkate double ayindani. Okay. Area is also changed. Both are changed. That's why R is directly proportional to L square. If you are able to understand, or in any other numerical, you can replace even L also. R is directly proportional to L by A. 1 by A, if you replace, you got R is directly proportional to L square. L square means 1 by A square. So R is directly proportional to, that is inversely proportional to A square also, you can say. Circular cross sectionality A equals to pi R square. So R is inversely proportional to, substitute pi R square there. Okay, you will get R power 4. This actually what we use, right? E case low here. My length is doubled and I use what? My R is directly proportional to, that is R1 by R2. In this case, I write L1 by L2 whole square. That implies R2 is equals to L2 by L1 whole square into R1. Okay, cross multiplication. So R2 is equals to what I suppose to write L2, 2L అయింది కదా నాన్న. L2 is, whereas L1 is L kada. So here this is 2 square times R1, that implies R2 is equals to 4 times to initial resistance, 4R. Okay, if the initial resistance is R. Right? ఈ మోడల్ అర్థమైందా నాన్న? Able to follow this model? Yeah, good. ఇదంతా tough ఇంకా we can easily understand. Why? Because both are simultaneously changing. So we have to change not only area of cross section also. Simple logic. Okay. These kind of models, when you come to exam, this is one example, Nana, what we have done. Applications, example 1. And example 2, what they say here, same question, but you have to understand smartly. Okay, ఏం అర్థం చేసుకోవాలి సార్? A wire of length L is stretched until its length is doubled. Stretch చేసామంటే once again you think నాన్న అంటే same as above. Yes, exactly. Length అంటే wire ని stretch చేసామంటే length increases, simultaneously area of cross section decreases, and again both are changing. Both are changing అంటే again R is directly proportional to L square అవుతుంది మనకి. Okay, so again we try to write here, then again R is directly proportional to L square in case of stretching. That implies R2 is equals to length double అయింది కాబట్టి above problem we already solved కదా నాన్న. So directly I am writing the answer R2 equals to 4R. Okay, ఇందులో ఏమైనా మీకు కన్ఫ్యూజన్ ఉందా నాన్న? I think no need to explain. Is it to be explained? Clear? Okay, ఎవరికైనా అవసరమారా? Here. No, okay, right. So ఇది అందరికి అర్థమైంది అనుకుంటున్నాం. So R2 is equals to 4R directly. Like length is doubled అంటే 2 square. 2 square is 4 times. Okay, good. వీటిలో మళ్ళీ again we have to solve the questions like percentages models. Small percentage, big percentage. Okay, a wire is stretched until its length is increased by number 1, like 2%. Number 2, increased by 40%. Small percentage, big percentage. Okay, then the percentage change in resistance is okay dash in the 2 cases. ఇందులో ఫస్ట్ ప్రాబ్లం ఎలా చేయాలన్నా? I think you remember the shortcut. If the percentage is small, direct ఏం చేసేది లేదు. Length is increased, అయితే length power how much? 2. అంటే 2 into 2%, 4%. I already taught in first year. అందరికి గుర్తుంది కదా ఈ మోడల్? When the percentage is small, stretched కాబట్టి again we have to use R is directly proportional to L square. Okay, small percentage అయితే length percentage given 2%. దీని పవర్ 2 కాబట్టి 2 into 2, 4%. Okay, directly shall I write like percentage change in R is equals to power, that is 2, into percentage change in length is 2%, 2 into 2, 4. Later, we have to apply log and differentiate. Is it required? Applying the log and differentiating and then substituting the values. No need. Indra meedna vallu dummies. Right. Ippudu respond avutunda. Good. Inka meelo respond avatలేదు. No need, Nisha. Okay, right, good. Aina respond avatలేదు. Ore pappus. All of you there? Dear pappus. Okay. Sorry, hurt deeply hurted, I think. Okay, no problem. Coming to here. For big percentage, how to solve the problem? Right? But at that time, applying log and differentiating method is not valid. Okay? Up to that time, we have to do in the original procedure. And what's like R2 by R1 is equals to ratio method. R is directly proportional to L square means L2 by L1 whole square. And already I taught in first year, in case of percentages, initial value better you take it as 100. I think all of you remember. L2 is initial value increased, length is increased. So plus percentage change. How much? 40%. So 100 plus 40 directly we write. Okay, this is a shortcut now. Taking the initial value as 100, final value as this L1 and 100 plus 40 percentage change. If it is decreased, we write 100 minus 40. Okay, increase 100 plus 40. So L2 by L1 whole square, that is 140 by 100. 140 by 100 means 7 by 5 whole square. And 49 divided by 25. Okay, this is the R2 by R1. But percentage, how you calculate, sir? Percentage is R2 by R1 minus 1 JC into 100. This is the method how to solve the percentage. So R2 by R1 is 49 divided by 25 minus 1 into 100. And you are getting how much, Nana? 14 by 25 into 100 after taking LCM. 14 or 24, sorry, 24 by 25 into 100. Right. 96 అవుతుందా నాన్న? Yes, exactly. 96%. Is it correct? Anirudh said it's 96. Siri Gazawada, correct, Anara? Yes. 96%. Okay, right. Yes, sir, correct. Amma, Surya, Unavara Talli. Good, 96%. Idi two methods, Nana. Small percentages, big percentages. Okay. ఈ percentages model తరువాత now we are entering into the series and parallel combinations, how we use. దానికి initially I am taking like this. ఎలా sir? Better I go to next page. Okay. Infinite length అది వెళ్ళిపోతానే ఉంది. ఎంతైనా స్క్రోల్ చేసుకోవచ్చు. Bon. Then here. ఈ బోర్డు బాగుందిరా, కాస్త అలవాటు పడిపోతే. Then we are coming to here. Suppose this is one example. A wire of length L is bent in the form of a circle whose resistance is R. Capital R. Okay, Nana? And length of the wire is given as L, its resistance is capital R. Idi vadana. Length of the wire is L, its resistance is capital R. Okay. Aithe, what he is asking finally, find the resistance between 2 points on the perimeter okay, where you are taking the 2 points on the perimeter, making an angle theta at the center. అంటే క్వశ్చన్ కొద్దిగా అర్థమైతే ఈజీగా చేసేస్తున్నాను. ఓకే, నేను మళ్ళీ డ్రాయింగ్ పెడుతున్నాను, చూద్దాం ఎంతవరకు ఇది సపోర్ట్ చేస్తుందో. ఈసారి సర్కిల్కి వెళ్తున్నాను. వచ్చిందా సర్కిల్? ఓయ్ యా, పర్ఫెక్ట్ సర్కిల్ ఐ గాట్. రైట్, దిస్ ఈస్ బెంట్ పర్లేదు బాగా. This is a circle, Nana. Okay, whose length is L. Keep in mind, total length. And suppose if you start from here, total length is L. And suppose the radius is R for the circle. Okay, L by 2 pi theta into R. అంతేనారా శ్రేణి విపీయ? కొద్ది జాగ్రత్తగా ఆలోచించు. I don't think it is the answer. If its radius is R, you are saying, ఏమైందిరా దీనికి? ఓ, నేను పెన్లోకి వెళ్ళలేదా? ఓకే, రైట్ రైట్ రైట్. ఊరు దీని తగలయ్యో, దీని సతాయిస్తా ఉంది. Right. If its radius is R, then we write in solution length of wire L is equals to 2 pi R, so that R is equals to L by 2 pi. We accept. Priya, what you are saying, by selecting 2 points on the perimeter here and there, the 2 points are making an angle theta at the center. Till here, correct only. What is the resistance of that part? And you are trying to see a resistance of this part, AB, shorter part. Accepted. This is L is equals to R theta, radius into theta, and its resistance R1 is equals to R theta, that is L by 2 pi into theta. Intena nana nu cheppin answer, I think. Kani between same A and B, you observe there one more part is there at the top. Idi kuda between A and B. That much part. And one more resistor is there kada between A and B, bigger one. But its resistance also you have to say. Its resistance is suppose R2. Okay, this is R1. Its resistance is R2. Then R2 is equals to the same like arc length is equals to r into theta. మరి మనం ఓన్లీ లెంగ్త్ రాస్తున్నట్టున్నాం రా. ఫర్ ఎల్ లెంగ్త్ రెసిస్టెన్స్ ఈజ్ ఆర్ కదా. టు అవాయిడ్ ద కన్ఫ్యూషన్ ఈ క్యాపిటల్ ఆర్ ని స్మాల్ ఆర్ రాద్దాం నాన్న రెసిస్టెన్స్ ని. ఇప్పుడు మనకి ఏ కన్ఫ్యూజన్ ఉండదు. ఓకే, 2 pi r, this is small r is equals to L by 2 pi, r1 is equals to r theta, L by 2 pi into theta. For L length resistance is r and r1 is equals to r theta by 2 pi. Correct enough? Okay. R2 is equals to r into what is the angle subtended by this sector nana? 2 pi minus theta kada. Angle subtended by the big arc 360 minus theta. Exactly. 360 minus theta and 2 pi minus theta. So the length of arc here I write r into theta. Theta is 2 pi minus theta, and then nothing but r is again L by 2 pi into 2 pi minus theta. Sorry. Right. L into 2 pi minus theta. Mali L length has the resistance capital R kabatti capital R by 2 pi into 2 pi minus theta. And actually we wrote here length of arc. Okay, after finding out length, L we are replacing with resistance. And then Mari are those two. And there is only one wire, but actually two wires are there. But they are looking like in parallel or series anana? They are looking like parallel. Parallel effective resistance we have to find out. That implies effective resistance between A and B. They are in parallel. So 1 by r equals to 1 by r1 plus 1 by r. Okay. E resistance let it be some r dash. Okay. So that is equals to what? R1 plus R2. 1 by R1 plus 1 by R2 lo 2 pi by R. Common this sound. Okay. After reciprocating 2 pi by R, 2 pi by R. Denominator lo you will get 1 by theta plus 1 by 2 pi minus theta. Okay, and you are getting after taking LCM 2 pi minus theta plus theta and 2 pi into 2 pi 4 pi square by r into theta into 2 pi minus theta. Therefore r dash equals to next page lo rasesannanu. Okay, a infinite long sheet lo ikkada raskuntunna. That implies r dash is equals to ఏమొచ్చిందిరా మనకి పైన కింద స్క్రోల్ చేద్దాం. r dash equals to r into theta into 2 pi minus theta divided by 4 pi square. ఏమైనా మిస్టేక్ ఉందా నాన్న ఇందులో? Once you check, any mistake is there? No. Surya Samhita. Any మిగిలిన word? No mistake. Yeah, okay, good. Correct only. Thank you. ఇది ఫైండ్ అవుట్ చేయాల్సిన విధానం. అంటే ఇనిషియల్లీ వేర్ we did the mistake మీకు అర్థమైంది కదా నాన్న? మనం ఓన్లీ వి థాట్ దట్ రెసిస్టెన్స్ బిట్వీన్ ద పాయింట్స్ ఏ అండ్ బి అంటే వీటికి ఓన్లీ దిస్ పార్ట్, కానీ అదొక్కటే కాదు ఇంకొకడు కూడా ఉన్నాడు. వి అండర్స్టూడ్ నౌ దోస్ టూ ఆర్ ఇన్ ప్యారలల్. ఇలాంటి మోడల్స్ నెంబర్ ఆఫ్ యూ హ్యావ్ దేర్ నన్. అంటే దిస్ ఇస్ ఫర్ సర్కిల్. ఏమో నెక్స్ట్ దే మే ఆస్క్ ఫర్ ద షేప్ హియర్. ఇలా ఒక స్క్వేర్ కడగచ్చు నేను. ఓకే, దిస్ ఈజ్ ఎ స్క్వేర్. మరి ఫర్ దిస్ స్క్వేర్ హియర్ it is of side length A. This is sorry. Right. For the side length A, right, now I understood. For the side length A, okay, with the side length A, we formed a square with the corners A, B, C, D. Kani, the question is a wire of length. Okay, ఏం చేస్తున్నాం? Wire of length. A wire of length L again is bent in the shape of square. Okay, and its resistance is R. And the resistance of total wire, L length wire is R. And each side resistance ఎంత అవుతుంది నాన్న? టోటల్ అయితే R అట. అంటే each side becomes R/4. 4 equal sides కాబట్టి resistance of each part becomes R/4 indirectly. Okay, R. అయితే here the question is find the effective resistance between the ends of మనకి possibilities 2 ఉన్నాయి. Of number 1 a side అడగాలి. Number 2 what is the other possibility నాన్న? Ends of a diagonal. అంతే, మనకి there are no options. Okay, of a diagonal. ఇదిరా రైట్. ఫస్ట్ క్వశ్చన్ కి ఆన్సర్ మీరు ఏమైనా చెప్పగలుగుతారా? above 3 sides are in series and the below and above are parallel. Oh, exactly correct. బాగా చెప్తారా? శ్రీనిధి ప్రియ, గుడ్. Who is this? Nishana. Okay, right. Srinidhi Priya gave the answer. 3L అంటే 3R/16 అంతేనా Srinidhi Priya? Exactly, I think. Right. అంటే ఏమైంది నాన్న? ఫస్ట్ క్వశ్చన్ 3R/26 శ్రీవాత్స 16. Yes, exactly. AB across the ends of a side అంటే AB is a side అనుకుంటే రెసిస్టెన్స్ R/4. బిట్వీన్ A and B ఈ పార్ట్ మొత్తం కూడాను is there between A and B. Okay, total it is between A and B అంటే R/4 plus R/4 plus R/4 they are in series కదా నాన్న అప్పుడు. Okay, so R/4 plus R/4 plus R/4 అంటే here between same A and B at the top you are getting 3R/4 అంటే they are in parallel కాబట్టి effective resistance మన వాళ్ళు ఈజీగా చేసేసారు. R' is equals to 1/R1 అంటే 1/R/4 that is 4/R plus 1/R2 3R/4 and 4/3R. After taking LCM 4 3s are 12 plus 4 16 and you are getting this is 16/3R. Therefore, R dash is equals to 3R by 16. They are correct. Okay. Idi across the ends of a side number. Across the ends of diagonal అన్నప్పుడు జాగ్రత్త చూడండి. R by 4. Is it correct? Srinidhi Priya. R by 4 plus ante. R by 4 plus R by 4. 2R by 4. Yes, yes, yes. Across the ends of diagonal ante between A and C, these two are looking to be in series. And one resistor here between A and C. I'm getting here, this is R by 4 plus R by 4, that is R by 2. These two. Between C and C, left side chuste, again R by 4 plus R by 4. R by 4 plus R by 4 is R by 2. Here this side. Again I am getting R by 4 plus R by 4, R by 2. They are in parallel. Identical kabatti R parallel is equals to R by n. Formula apply cheste R by 2 by 2. That is R by 4. Okay. ఇక్కడ మీరు జాగ్రత్తగా అబ్జర్వ్ చేస్తే the effective resistance across the diagonal is equal to the resistance of a side. Observe chesara. Okay. This is in case of you are expecting only the square. Kani nenantanu, suppose the same wire is bent in the shape of diagonal రావాలంటే even side side తీసుకోవాలన్నా 1 2 3 4 5 6 సరిపోయా 1 2 3 4 5 ఓయ్ ఎక్కువ వచ్చారా what is this nonsense here 1 2 3 4 5 6 then only you can produce the diagonal మనకు వస్తుంది even number of sides if you bend. ఇప్పుడు కూడాను I am asking what? Find the effective resistance between the ends of a diagonal. Mali how much you get there now? 6 sides kabatti each side will be R by 6. Okay. Yes. And mali R by 6 plus R by 6 plus R by 6. This is R by 3. That side also R by 6 plus R by 6 plus R by 6 R by 3. They are in parallel between these 2 points. Parallel ante R by 6. What you understood? 4 sides aithe R by 4, 6 sides aithe R by 6, n sides aithe R by n. Am I right? This is a regular polygon bent into the regular polygon. ఈ పాయింట్ ని ఇక్కడ యాడ్ చేసుకుంటున్నాం. ఓకే, we are adding the point here. If there are n number of sides coming to that, under note, can you keep in mind how many number of sides ఉండాలన్నా even or odd? Even కదా. So a wire of length L and resistance R is bent in the shape of a regular polygon of even number of, yes, yeah, even అదే రాస్తుంది, even number of sides okay, then the resistance across a diagonal is equals to the resistance of a side. Resistance of a side that is equal to R by N. ఇది మీకు అర్థమైపోయింది. కానీ ఇది కొద్దిగా జాగ్రత్త చెప్పాలన్నా, ఇదే ఫర్ ఎగ్జాంపుల్ మీకు here 4 sides కాబట్టి అబ్జర్వ్ చేయండి, వాట్ యు గాట్ ద ఆన్సర్ 4 minus 1 divided by 4 square. ఇది across a side నాన్న 4 minus 1 into R divided by 4 square. If it is 6 sides, 5R by 36 exactly. If it is of n sides and ide a regular polygon, n minus 1 into R by n square. Am I right? Yes. Same point I am going to add here. And across a side, not a diagonal, the effective resistance. The resistance is equals to, I write. Here resistance is equals to n minus 1 into R divided by n square. We short this. Even actually basic models wire bent in the shape of like given. ఒక్కొక్కసారి మిమ్మల్ని బాగా ఇరిటేట్ చేస్తాడు. ఇరిటేట్ అంటే హౌ సార్ అంటే, look at the question. Here a wire is bent in the form of a circle. Correct? Full circle గా ఇలా బెండ్ చేసి వదిలేసాడు. పోనీ వదిలేసాడా? నో. ఓకే, the full length of the wire second part is bent like this. ఓకే, ఇది టోటల్ లెంగ్త్ ఆఫ్ ద వైర్. అంటే ఇంత ఇక్కడ నుండి ఇక్కడ దాకా స్ట్రైట్ లైన్, రిమైనింగ్ పార్ట్ సర్కిల్. ఆ స్ట్రైట్ లైన్ కూడా ఎలా ఉంది అంటే, హియర్ ఇఫ్ ద రేడియస్ ఆఫ్ దిస్ వన్ ఈజ్ ఆర్, లెంగ్త్ ఆఫ్ ద వైర్ స్మాల్ ఆర్ తీసుకుందాం, మళ్ళీ కన్ఫ్యూజన్ లేకుండా. ఓకే, ఇఫ్ ఇట్ ఈస్ స్మాల్ ఆర్, ద లెంగ్త్ ఆఫ్ దిస్ వన్ ఈజ్ స్మాల్ ఆర్. అర్థమైందా ఇప్పుడు? అప్పుడు టోటల్ లెంగ్త్ ఆఫ్ ద వైర్ దట్ ఇంప్లైస్ L is equals to, చెప్పగలుగుతారా మీరు లెంగ్త్ ఆఫ్ ద వైర్? A wire is bent in the shape as shown. And some part is a circle, other part is a straight line. Appudu length of wire is equals to em cheppalana nenu, up to here length of wire is R. Appudu jagrataga observe cheste, what is the angle subtended by the straight line nana? Straight line work enta angle chestundi? Idi equilateral triangle kada, idi 60 degrees. 60 degrees ante 1/6 of 2 pi. 2 pi lo sixth part. Okay, and the remaining angle subtended by the circle is here, this angle. Shall I write 2 pi by 5 nana? Sorry, 2 pi by 5, nonsense. 5 pi by 6 nana? And 300 degrees. 5 pi by 6 and 300 kada? Right, 5 pi by 6. So 5 pi by 6 angle, what is the length? Malli arc principle ega, L is equals to R theta, and R into theta is 5 pi by 6. అర్థమైందా? ఇది లెంగ్త్ ఆఫ్ వైర్. ఇప్పుడు మీకు క్వశ్చన్ ని వదిలేస్తున్నాను. ఓకే, యూ హ్యావ్ టు సాల్వ్ ఇట్. If these 2 points are A and B, okay, resistance of full wire, ikkada question, resistance of total wire is or find the resistance between A and B. చేయగలుగుతారా నాన్న? 5/6 150 అవుతుందా? 5/6 అంటే 30 degrees. ఇది 5/3 కదా? 5/3. సారీ నాన్న, అయితే 5/3 ఇది. 5/3 అంటే 60 degrees. 65 yes exactly, and ఇది 5/3. థ్యాంక్ యూ రా అనిరుద్. 5/3 exactly, you are right. ఓకే, ఇది స్మైలీ సింబల్ వేయలేదు నువ్వు. థ్యాంక్ యూ చెప్పాను అనిరుద్. ఈమోజీ స్మైలీ చెప్పాలి కదా నువ్వు నాకు. ఓకే, వెల్కమ్. రైట్, గుడ్ అది. రైట్, సో హియర్ దిస్ ఈస్ the question I am leaving it to you all, Nana. Try to solve it. Okay. So shall I stop the class here? Okay, Nana.